This simulation models the warranty returns processing facility. The conveyor system supporting this facility consists of 87 loading stations and 13 unloading points. Recirculation occurs if an unloading point buffer is filled. The conveyor will transport and sort standard parts, which are represented by white trays, bulk parts, which are represented by the smaller gray boxes, and motherboards represented by the larger brown boxes. Staffing utilization is represented by showing idle workers in blue and active operators in green. We will now take a closer look at the major operations of the facility, beginning at the receiving dock. As parts are received, they are unloaded from the truck, palletized, staged, and delivered to the depalletizing stations, or returns induction. Once a pallet has been consumed at an induction station, it triggers the order of a new pallet. Each station has a buffer size of 2 pallets. Transport of the pallet from receiving to the induction station is a labor-driven process. Staffing is low due to the long lead time of ordering a new pallet versus a relatively fast delivery rate. It is assumed that the facility has enough staffing for this process, therefore this process has not been simulated. Pallets are inducted at the approximate rate of 23 pallets per hour. 77% of the stations are dedicated to standard parts, 20% are dedicated to motherboards, and 3% are dedicated to bulk parts. Bulk and motherboards are directly loaded onto the conveyor, while standard parts need to be sorted by destination onto trays. Once the trays are full, they are placed onto the conveyor. Trays and parts travel via conveyor to their volume-based storage destination. Motherboards are unloaded and palletized in their own area. Once a full pallet has been built, it is transported to shipping. High-volume standard part trays are sorted into boxes based upon SKU and vendor in the case flow rack. Once sufficient boxes to create a full pallet for a specific vendor have accumulated between the flow rack and bins, the high-volume part boxes are consolidated and palletized along with boxes from the medium and low-volume bins and transported to shipping. Medium and low volume trays are sorted by SKU and vendor into bin shelving. Once sufficient boxes to create a full pallet for a specific vendor have accumulated between the bins and flow rack, the medium and low volume part boxes are consolidated and palletized along with boxes from the high volume case flow and transported to shipping. Parts stored in bin shelving for longer than a set duration of time are boxed and palletized even though the box is not yet full. Bulk parts, recoverable scrap, and non-recoverable scrap are handled in the same manner as motherboards in that they have their own pallet building area. Once a full pallet of bulk parts for a specific vendor has been built, it is transported to shipping along with full pallets of scrap. The average system throughput rate has been determined to be 3,500 parts per shift using 87 stations. This resulted in 224 full pallets produced and delivered to the shipping docks. Operator utilization ranged from a low of 54% in the scrap area to a high of 86% in the high-volume flow rack zones.